Hello, my name is Savannah Ramsey. I am in 7th grade. I go to Southeastern Junior High, and this is my first year in Science Club.
Hello, my name is Amanda Stevens. I go to Southeastern Junior High. I'm in 7th grade, and this is my first year in Science Club. And the name of our project is Conservation with Biostimulation using microbial fuel cells to generate energy.
Before we begin, we would like to thank our sponsors, Mrs. Guyman and Miss Wheel, for all their help and support. And we'd also like to thank you for taking the time to judge and listen to our project.
In order to reduce pollution, we need to find alternate energy sources. With microbial fuel cells, energy can be extracted from wastewater. They convert organic matter to electricity with bacteria leaving behind clean water. Money and resources can be saved when using wastewater as fuel.
We built two-chamber microbial fuel cells. They contain two electrodes, the anode and the cathode, a proton exchange membrane, which is right here, and it's also what we're making in this picture, and an external circuit, which is this. In the anode chamber is the mud, and the mud contains microbes. The microbes eat the organic matter and extract electrons. During digestion, that's when they make the electrons and protons. And the electrons run through the external circuit into the cathode chamber, which is containing a conductive saltwater solution. The electrons and protons combine with oxygen to create water.
We got our benthic mud from a pond. We got this mud from the bottom layer. This mud contains organisms called benthos. Benthos survive on organic matter and food source. They have adapted to their environment where they can live without oxygen and sunlight. We added bone meal to half of our microbial fuel cells to see if it would stimulate microbe growth. Bone meal is finely ground animal bones used as an organic fertilizer or nutritional supplement. It is also high in calcium and phosphorus.
As we said earlier, developing an alternative energy source is critical to protect the environment. The purpose of this project was to create a new way to create electricity, the microbial fuel cell. We compared benthic mud with and without bone meal to see if biostimulation would increase the amount of power generated by the microbial fuel cells.
We predicted that the microbial fuel cell with the addition of bone meal would generate more power than the microbial fuel cell without biostimulation. We also predicted that the microbial fuel cells would generate a measurable amount of power.
So first we construct the microbial fuel cells, and then we made the electrodes and the salt bridges. We put them all together to make two sets, one for the bone meal and one without bone meal. They both have the benthic mud in them. And then we tested them 2 times a day for 15 days. And we conducted 2 more trials after that and averaged the results and the standard deviation.
Our independent variable, the thing we changed, was microbial fuel cell type. We had benthic mud only, and we also had benthic mud and bone meal. Our dependent variable, the thing we measured, was power output, which is P equals V squared divided by R. And our controlled variables, the thing we kept consistent, were microbial fuel cell construction, benthic mud source, multimeter, testing environment, and testing technique.
So for our results, we have tables, and as you can see, we tested 2 times a day, and then we averaged the results of those readings, and we use a 220 resistor. That is why our resistance is always 220. And then we averaged the total power overall in this column. We did this for 15 days, and then we did this for both types. After that, we conducted 2 more trials. Next, we averaged the results. And we used the same layout, and we did this for both types again. And lastly, we calculated standard deviation to show the results in our, or to show the variation in our results. So, in our first graph, along the x-axis are the reading days of our project, and then the y-axis is the average power. This graph is kind of like a timeline because it shows over all the days how much power they're generating. And as you can see, the green line, which is the one with bone meal, kept rising and rising over the days and kept growing and getting more power. And then the one without bone meal would just stay the same, stay low, and it hardly generated any power whatsoever. In our next graph, is kind of, again, like over the days. We have day 1, day 5, day 10, and day 15. As you can see, the ones with bone meal generated significantly more power than the ones without bone meal. And over the days, it kept growing and growing in this graph. Our last graph is basically like our overall graphs, or our overall graph. Again, you can see that the one with bone meal generated significantly more power over time throughout the whole testing. And we can say that it was always better because the error bar lines in both of them don't overlap.
We predicted that the microbial fuel cell with the addition of bone meal generated significantly more power than the microbial fuel cell without biostimulation. After conducting 3 trials and averaging the results, it was determined that our hypothesis was supported. Based on calculated standard deviation, the microbial fuel cell with the addition of bone meal generated significantly more power than the microbial fuel cell without biostimulation. This was because the bone meal is rich in nutrients needed for rapid microbe reproduction. We also predicted that the microbial fuel cells would generate a measurable amount of power. Again, it was determined that our hypothesis was supported. This was probably due to the presence of the microbes creating electrons in both types of microbial fuel cells.
Great effort was made to construct the microbial fuel cells the same and conduct the experiment in a controlled manner. However, there was some variation in the results. We couldn't control the exact quantity of microbes in each microbial fuel cell, but we got the mud from the same location. And overall, our results did show consistency, indicating that the data was reliable.
We also learned that our microbial fuel cells generated enough power to charge your tablet, phone, iPad, computer, and Chromebook, and also work a ceiling fan. Thank you.